In this video, I'm going to look at your second assignment from Monday. This was page 4 in your review packet. It's called Applying Properties of Integer Exponents. And I'm going to solve number 3, number 5, number 7, and number 9 with you. I'll begin with number 3. When I looked at number 3, the first thing I noticed is that I have some parentheses and that there's an exponent outside of those parentheses. When you have an exponent outside, what that tells you is that the exponent is actually being attached to everything on the inside. And what we should also notice that everything on the inside already had an exponent attached to it. So in fact, this 3 actually has 2 exponents attached to it. It has a -4 and a -2 attached to it. When you have a base that has 2 exponents attached to it, we're going to use the power rule. And what the power rule tells you is that we're going to multiply those exponents. So I'm going to do -4 times -2, and that will give me +8. I'm then going to do 6 times -2 to get -12. For the bottom, I'll do 3 times -2 to get -6. And finally, I'll do -1 times -2 to get +2. I then notice that in the numerator, I have the same base and I'm multiplying. When you have the same base and you're multiplying, we're going to use the product rule. And the product rule says that you're going to add your exponents. So 8 plus -12 gives me -4. In the denominator, I also had the same base. They're both 6s. So I'm going to use the product rule again. And -6 plus 2 also gives me -4. We don't like negative exponents, so we're going to use the negative exponent property. This tells you all you have to do is switch the positions to change the sign of the exponent. In other words, since the 3 to the -4 is on the top, all I need to do is throw it to the bottom. And since the 6 to the -4 is on the bottom, all I need to do is throw it to the top. And when you swap their positions, the sign of your exponent will change. They went from -4 to +4. Typically, this is where you would stop, but since the directions tell us to evaluate, what that means is they want us to know what does this actually equal. Does it equal 5, 15, 32? So to figure that out, we have to do a couple more steps. So what I did is I asked myself, what does this statement actually mean? Well, 6 to the 4th power, that means 6 times 6 times 6 times 6. And 3 to the 4th power means 3 times 3 times 3 times 3. What I actually created is 4 separate division problems. I have 6 divided by 3 4 times. And 6 divided by 3 actually gives you 2. So what I'm actually creating is 4 separate 2's. And this is easy to multiply out. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 gives me 16. So our final answer is 16. This hot mess that we had at the beginning actually equals 16. Now let's look at number 5. For number 5, what I notice is that I have the same base in the numerator and the denominator. So I have a 6 and a 6, a 17 and a 17, and a 2 and a 2. And they're separated by a fraction bar, and a fraction bar means we're dividing. So when you divide the same base, we're going to use the quotient rule. And the quotient rule says that you're going to subtract your exponents. So I'm going to do -3 take away 5. And -3 take away 5 gives me -8. For the base 17, I'm going to do 3 take away -4. Be careful here. 3 take away -4, that's the same thing as saying 3 plus 4. And that gives you +7. And finally, for the 2's, there's an imaginary 1 here. So we're going to have 1 take away -1. Once again, be careful. 1 take away -1 is the same thing as 1 plus 1, which gives you +2. Once again, I have a negative exponent. I need to get rid of that. By the negative exponent property, I just need to throw it to the bottom. Since it's on the top, there's an imaginary 1 underneath. We know this is a fraction. We just don't need to write it. Since this is at the top, I'm going to throw it to the bottom, and the sign will change from -8 to +8. There's nothing else I need to do. We have our answer with positive exponents, so I can box this answer, and we can move on to number 7. Number 7, I noticed that I have exponents again in the inside and an exponent on the outside. I'm going to use the power rule. I'll begin with the first part. -3 times -4 gives me +12. A -8 times a -4 gives me a +32. A -2 times a -4 gives me an 8. And a -2 times -4 once again gives me an 8. I then once again notice that I have the same base being divided. When you have the same base being divided, you can use the quotient rule. This will be 12 take away 8, which will give me +4. And then 32 take away 8 will give me 24. Since both exponents are positive, I'm happy I'm done. I can box this answer. The parentheses here are totally optional. You can remove them or keep them. It's up to you. And finally, number 9. I have the same setup as number 7 and number 3. I have exponents on the inside. and an exponent on the outside, we'll use the power rule. 6 times 4 gives me 24. Negative 3 times 4 gives me negative 12. And negative 3 times 4 gives me negative 12. Once again, I have the same base and they're dividing. A 3 and a 3 are being divided here. So I'm going to use the quotient rule. A negative 12 take away a negative 12 is the same thing as a negative 12 plus a 12. That will give me 0. Negative 12 plus 12 is 0. And then we typically would stop here unless you remember your other exponent rule, and I remember it. So when you have anything raised to the 0 power, anything raised to the 0 power is actually 1. So I can rewrite this as 5 to the 24th times 1. And anything multiplied by 1 is itself. So this is just simply 5 to the 24th power. And this is your final answer.